Imagine looking up at the night sky, seeing thousands of stars twinkling above, and wondering what else is out there, what lies beyond what we can see. These questions have driven humanity for centuries, inspiring countless discoveries. And today, we're about to explore one of the most ambitious scientific tools ever created to answer them, the James Webb Space Telescope, or JWST. So why was James Webb built? Well, to put it simply, the universe is vast, almost unimaginably vast. And even with our best telescopes on Earth, there are limits to what we can see. Our atmosphere, for example, blocks some forms of light. Infrared light, which is like the heat glow from distant stars and galaxies, is mostly absorbed before it reaches us. That's a problem, because a lot of the universe's secrets are hiding in that invisible light. James Webb was designed to see that hidden universe. Unlike its predecessor, the Hubble Space Telescope, JWST can look further back in time and deeper into space. It's essentially a time machine, allowing scientists to see the first galaxies that formed after the Big Bang over 13 billion years ago. Think about that for a moment. 13 billion years. That's almost incomprehensible. The light JWST captures today started its journey long before our solar system even existed. Fun fact, JWST's primary mirror is about 6.5 meters wide. That's more than twice the width of Hubble's mirror. The bigger the mirror, the more light it can collect, and the farther it can see. So, it's like swapping a small backyard telescope for a giant observatory in space, one that can look across the entire universe. But the purpose of James Webb isn't just to gaze at distant galaxies. Scientists built it to answer fundamental questions about the origins of stars, planets, and even life itself. How do stars and planets form? What's in the atmospheres of faraway exoplanets? Could some of these planets support life? JWST was built to explore all of these questions and more. Here's another interesting detail. JWST wasn't just launched into low Earth orbit like Hubble. It's positioned nearly 1 million miles away from Earth, at a point called Lagrange 2, or L2. This location allows it to stay stable and avoid the heat of our planet, which is crucial because infrared instruments are extremely sensitive. Even a tiny bit of warmth can interfere with the observations. It's almost like putting a camera inside a freezer so it can take the clearest pictures possible. And JWST's sun shield? That's a 5-layer, tennis court-sized shield that blocks the sun's heat and light, keeping the telescope cold enough to detect the faintest glimmers of the universe. Imagine standing in direct sunlight with a giant umbrella, but instead of rain, the umbrella blocks the heat of the sun for years at a time. That's basically what JWST is doing for its delicate instruments. So, in short, James Webb was built because we wanted to push the limits of what we can see, to look back in time, and to uncover mysteries that have puzzled scientists for decades. It's a bridge between the known and the unknown, a tool that can finally give us a glimpse of the universe as it was billions of years ago. Did you know? JWST took more than 20 years to design and build. Thousands of engineers, scientists, and technicians from around the world contributed to this one telescope. And when you see its first images, you're looking at the culmination of decades of human curiosity and effort, all in one golden mirror. So why was JWST built? To explore the invisible, to peer back to the dawn of time, and to help us understand our place in the universe. In the next section, we'll take a closer look at how this incredible telescope actually works, and why it's capable of seeing things that no telescope has ever seen before. Now that we know why James Webb was built, let's take a closer look at how this incredible telescope actually works. Understanding its design will help us appreciate just how sophisticated and unique it is. At its heart, JWST is all about capturing light, specifically infrared light. Infrared is basically heat radiation. Everything that has temperature gives off infrared, from a glowing ember to distant stars. But because Earth's atmosphere blocks most infrared, JWST had to go all the way into space, nearly 1 million miles away, to get a clear view. The telescope's most striking feature is its massive primary mirror, made of 18 hexagonal segments coated in gold. Gold? Yes, gold. Not for looks, but because gold is an excellent reflector of infrared light. Each segment can be adjusted with microscopic precision, almost like tuning a giant musical instrument, to focus light perfectly from objects billions of light years away. Fun fact, if you could lay JWST's mirror flat, it would cover about a tennis court. That's huge for a space telescope. The large size is crucial because the bigger the mirror, the more light it collects, and the fainter objects it can see. But capturing light is only part of the challenge. Infrared instruments are extremely sensitive to heat, including heat from the sun, Earth, or even the telescope itself. That's where the sun shield comes in. JWST has a 5-layer, tennis court-sized shield made of a special material called Captain. This shield blocks heat from the sun, keeping the telescope at an incredibly cold temperature, less than -370 degrees Fahrenheit, so its sensors can detect the faintest signals from the universe. Another fun fact, the sunshield layers are thinner than a human hair, yet each layer helps reduce heat by thousands of degrees. It's like stacking dozens of ultra-thin blankets in space to protect the telescope from sunlight. JWST also has a set of sophisticated instruments like cameras and spectrographs, which break down light into its component colors. This allows scientists to determine what distant stars, galaxies, or planets are made of. Imagine looking at a rainbow from a distant planet and being able to tell it has water, methane, or even hints of organic molecules. That's the kind of detailed observation JWST can do. One more cool detail. JWST was folded like origami to fit inside its rocket, and then carefully unfolded in space. A process that took about a month. Every mirror segment, sunshield layer, and instrument had to deploy perfectly. It was one of the most complex mechanical feats in history, and once complete, JWST became fully operational at its location near L2. So how does it all work together? The mirrors collect faint infrared light, focus it onto the instruments, and the instruments analyze it in incredible detail. Then, this data is sent back to Earth, where scientists process it into images and measurements we can understand. The result? Stunning images of galaxies, nebulae, and distant exoplanets that were invisible to Hubble and other telescopes. Did you know? JWST can see objects 10 to 100 times fainter than Hubble. That means it can detect the light of some of the earliest stars in the universe. In a sense, it's not just looking at space, it's looking back in time. In short, James Webb works because every part of it, from its gold-coated mirrors to its sunshield, is meticulously designed to detect the faintest infrared signals across billions of light years. It's a perfect combination of engineering, physics, and imagination. In the next section, we'll explore some of the amazing discoveries JWST has already made, and why these findings are changing the way we understand the universe forever. Now that we understand why JWST was built and how it works, let's dive into some of its first discoveries. These early findings are already reshaping our understanding of the universe, and they're just the beginning. One of JWST's most exciting achievements is peering back in time to the very first galaxies. Because light takes time to travel, when JWST captures the light from a distant galaxy, it's actually showing us what that galaxy looked like billions of years ago. Imagine looking at a baby photo of the universe itself. Incredible, right? Fun fact, some of the galaxies JWST has spotted existed just 200 to 400 million years after the Big Bang. That's astonishing because these galaxies formed when the universe was less than 3% of its current age. Studying them helps scientists understand how the first stars ignited and how galaxies grew over time. JWST isn't just showing us the distant past. It's also helping us understand our cosmic neighborhood. For example, it has captured incredibly detailed images of nebulae, the colorful clouds of gas and dust where stars are born. By studying the light from these nebulae, scientists can see how stars form and how their environments evolve over millions of years. Here's a fun analogy. Think of a nebula as a giant cosmic nursery. JWST lets us peek inside and watch the baby stars grow, sometimes surrounded by rings of dust that could eventually form planets. It's like watching the universe build itself in real time, but on a timescale that spans millions of years. Another fascinating discovery is JWST's ability to analyze exoplanet atmospheres. Using its infrared instruments, The telescope can detect molecules like water, methane, carbon dioxide, even hints of chemicals that could suggest the potential for life. Imagine pointing a telescope at a planet dozens of light years away and being able to smell its atmosphere. That's essentially what JWST is doing. Did you know? JWST has already found signs of complex molecules in exoplanet atmospheres that were previously invisible to astronomers. This is a huge step forward in the search for life beyond Earth, and it's only the start of its mission. But perhaps one of the most awe-inspiring discoveries is the sheer variety and scale of galaxies JWST has revealed. Some galaxies are tiny and compact, while others are enormous, stretching across tens of thousands of light years. And the detail is staggering. You can actually see the individual star clusters, the swirling arms of spiral galaxies, and even distant supernova explosions in stunning clarity. JWST has also detected cosmic structures that challenge previous models of galaxy formation. Some galaxies appear older or more evolved than scientists expected for their age. This raises fascinating questions. Did the first galaxies form faster than we thought? Are there processes in the early universe we still don't understand? JWST is helping us find the answers. Here's a reflective pause. Each new discovery is like opening a window into a part of the universe we've never seen before. Every photon of light JWST captures is a message from the distant past, carrying clues about how the cosmos began, how it evolved, and perhaps even how life might arise elsewhere. So, in summary, JWST's first discoveries are already groundbreaking. Early galaxies forming shortly after the Big Bang, intricate nebulae revealing star formation, exoplanet atmospheres hinting at life, and cosmic structures that challenge our understanding of the universe's growth. And this is just the beginning. Over the next decade, JWST promises to uncover more mysteries that we haven't even imagined yet. In the next section, we'll explore some of the most surprising and mysterious findings that JWST has captured, images and data that leave even the most experienced scientists scratching their heads and wondering what secrets the universe is hiding. As we continue our journey through the James Webb Space Telescope's discoveries, some of the findings have left scientists genuinely amazed, and sometimes a little confused. These are the moments when JWST isn't just answering questions. It's raising new ones. One of the first surprises came from galaxies that formed incredibly early in the universe. JWST has observed galaxies that appear far more developed than scientists expected for their age. Think of it this way. It's like finding a teenager who has already built a skyscraper. How did these galaxies form so quickly after the Big Bang? The telescope is giving us clues, but the full story is still unfolding. Fun fact, some of these early galaxies are packed with stars so densely that a single galaxy contains billions of them, shining brightly across billions of light years. It's hard to imagine just how massive and ancient these structures are. Another astonishing discovery is the complexity of nebulae and star-forming regions. JWST's infrared eyes reveal intricate filaments of gas and dust twisting and turning in ways that were invisible to previous telescopes. These cosmic clouds are like nature's own sculpture, shaped over millions of years by gravity, radiation, and the explosive energy of nearby stars. Did you know? In some of these nebulae, JWST has detected signs of organic molecules, the building blocks of life. While this doesn't mean we've found life, it's a thrilling glimpse into how the ingredients for life are spread throughout the cosmos. JWST has also made some unexpected observations of exoplanets. For example, the telescope has captured detailed spectra of their atmospheres, revealing chemical compositions we didn't anticipate. Some planets have water vapor, while others contain exotic molecules like carbon monoxide or methane in surprising amounts. Every new measurement challenges our models of how planets form and evolve. Here's a curious thought. Could some of these distant worlds host life in forms we haven't even imagined yet? JWST is bringing us closer to answering that age-old question. Are we alone in the universe? One of the most mysterious discoveries is the detection of cosmic oddities, objects that seem to defy current scientific models. Tiny, faint galaxies, unusual star clusters, and distant quasars with strange behavior have all been captured by JWST's instruments. Scientists are studying these anomalies carefully because each one could hold a clue about the hidden physics of the early universe. Fun fact: JWST can detect light from objects so faint that they would be invisible to the naked eye or even Hubble. This means the telescope is revealing parts of the universe we didn't even know existed. Every image, every spectrum, is a discovery waiting to happen. Some discoveries are also surprisingly beautiful. Take the first images of nebulae like the Carina Nebula or the Southern Ring Nebula. JWST shows incredible detail, colors, and structure, almost like a cosmic painting. These aren't just pretty pictures. They're scientific goldmines, revealing the processes that shape stars and galaxies over millions of years. And here's a reflective question. When we look at these distant galaxies, some over 13 billion light-years away, we're seeing light that started traveling when the universe was still in its infancy. Each photon is a message from the past, a story of creation that traveled billions of years to reach us. Isn't it incredible to think that a single telescope can connect us to the very beginning of time itself? In short, JWST's early discoveries have surprised us with early galaxies that shouldn't exist, complex nebulae hiding organic molecules, exoplanets with unexpected atmospheres, and cosmic objects that challenge our understanding of physics. These discoveries aren't just data. They're invitations to imagine, to question, and to explore further. In the next section, we'll look at how these discoveries are changing the way scientists think about the universe and what the future might hold for humanity's exploration of the cosmos. As we've seen, the James Webb Space Telescope is already transforming our understanding of the universe. But why does this matter for the future? Why is JWST such a game-changer for astronomy, science, and even for humanity as a whole? First, JWST is helping answer some of the biggest questions we've ever asked. How did the universe begin? How do stars and galaxies form? Are we alone in the cosmos? These aren't just scientific curiosities. They shape our understanding of everything, from the planets we live on to the very origins of life. Fun fact: some of the light JWST observes has been traveling for over 13 billion years. That means we are literally looking back in time, witnessing the universe as it was just a few 100 million years after the Big Bang. The insights we gain aren't just academic. They tell us our own story and our place in the vast cosmos. JWST is also paving the way for future exploration. By studying exoplanets in detail, it helps scientists identify which worlds might be worth exploring with future missions. Think of it as scouting the universe for places where life might exist, or where humans could potentially visit in the far future. Another remarkable aspect is how JWST inspires collaboration and innovation. Thousands of scientists, engineers, and technicians from around the world contributed to its design and launch. Every challenge, from creating the sunshield to folding the mirrors, pushed the boundaries of engineering. The technologies developed for JWST will likely benefit other fields on Earth, from materials science to imaging technologies. Did you know? JWST operates so far from Earth that it communicates via a complex relay system, sending data across nearly 1 million miles of space. That's farther than any telescope humans have ever sent. Its success shows what's possible when science, technology, and human determination come together. JWST also inspires the next generation. Students, young scientists, and dreamers around the world see its discoveries and realize that the universe is still full of mysteries waiting to be solved. Every image, every spectrum, every tiny discovery encourages curiosity and imagination, a vital part of human progress. And finally, JWST reminds us of something profound. Even in a universe that can feel overwhelmingly vast, small steps in exploration can yield enormous insights. From detecting the earliest galaxies to analyzing the atmospheres of distant exoplanets, JWST proves that careful observation, patience, and innovation can reveal the unimaginable. So, why does JWST matter for the future? It answers big questions, guides future exploration, drives innovation, inspires generations, and connects us to the universe in ways we could never have imagined. It's more than a telescope. It's a time machine, a cosmic messenger, and a beacon for human curiosity. In the next section, we'll reflect on the most breathtaking images JWST has captured so far and consider what they teach us about the beauty, mystery, and scale of the cosmos. Now let's turn our attention to something that truly captures the imagination: the incredible images that the James Webb Space Telescope has sent back to Earth. These are not just pictures. They are windows into the universe's deepest secrets. One of JWST's first iconic images was of the Carina Nebula, a vast cloud of gas and dust where stars are born. JWST's infrared vision penetrates the thick dust, revealing structures so intricate they look like delicate cosmic lace. Imagine a nursery where stars are forming, with tendrils of gas twisting and glowing. JWST lets us see every detail. Fun fact, the Carina Nebula is about 7,500 light-years away, which means the light we're seeing today left that nebula 7,500 years ago, long before recorded history. Each photon is a tiny messenger, carrying the story of creation across space and time. Another awe-inspiring image comes from Stephan's Quintet, a group of 5 galaxies interacting in a cosmic dance. JWST's clarity shows the gravitational pull and tidal forces stretching the galaxies, sparking star formation in regions where previously we only saw darkness. It's like watching a slow-motion ballet that unfolds over millions of years. Did you know? These galaxies are interacting so strongly that stars and gas are being flung out into space, creating streams of material that might eventually form new galaxies of their own. In a sense, we're witnessing the recycling of the universe. JWST has also captured distant galaxies that existed just a few 100 million years after the Big Bang. The images show faint, tiny specks of light, each representing billions of stars forming in the early universe. These glimpses help scientists understand how the first galaxies came together, how they grew, and how they evolved into the majestic galaxies we see today. Another breathtaking image is the Southern Ring Nebula, a dying star shedding layers of gas and dust. JWST reveals the shells of material with astonishing detail, helping astronomers study how stars end their lives and enrich the universe with elements like carbon, oxygen, and nitrogen, the very building blocks of planets and life. Here's a reflective thought. Every image from JWST is a story. A nebula tells the story of birth, a galaxy tells the story of growth, and a dying star tells the story of transformation. Through these images, we begin to see the universe not as a static place, but as a living, evolving entity. Fun fact, JWST's images also show incredible color and texture, but it's important to remember, some colors are enhanced or mapped from infrared light to visible colors so we can interpret the data. In other words, we're translating cosmic signals into a visual language that humans can understand. Finally, these images remind us of our place in the cosmos. From the tiniest stars to galaxies billions of light-years away, we are part of a universe that is vast, dynamic, and full of mysteries. JWST doesn't just give us pictures. It gives us perspective, curiosity, and wonder. In the next section, we'll reflect on what the James Webb Space Telescope means for humanity, the future of exploration, and the ongoing quest to understand the cosmos. As we reach the end of our journey through the James Webb Space Telescope, it's time to reflect on what we've seen and why this telescope matters, not just to scientists, but to all of us. JWST has opened our eyes to the universe in ways we could only imagine a few decades ago. From glimpsing the first galaxies that formed after the Big Bang to capturing breathtaking nebulae where stars are born and die, it shows us the universe as a place of wonder, mystery, and incredible beauty. Fun fact, every photon that JWST detects has traveled across billions of light-years to reach us. In a very real sense, the telescope is connecting us to the distant past, showing us stories that began long before humans even existed. But JWST is more than just science. It's a symbol of human curiosity and ingenuity. Think about the engineering feat of folding a telescope like origami, sending it nearly 1 million miles from Earth, and unfolding it perfectly in space. Every mirror, Every sunshield, every instrument represents thousands of hours of human creativity, collaboration, and problem-solving. Here's something to ponder. What does it mean for us that we can explore galaxies billions of light-years away while still standing on our tiny planet? JWST reminds us that even as small humans in a vast universe, our curiosity can take us to unimaginable heights. JWST also inspires the next generation. Young scientists, engineers, and dreamers can see these discoveries and realize that space exploration isn't just science fiction. It's happening right now. Every stunning image, every new piece of data is a spark that could ignite the next breakthrough in astronomy, technology, or even life itself. And perhaps the most profound takeaway is this: the universe is vast, mysterious, and constantly evolving. JWST has given us a glimpse of its wonders, but it has also shown us how much more there is to discover. For every answer we find, new questions arise, reminding us that exploration never truly ends. So, as we look up at the night sky, let's remember the James Webb Space Telescope, not just as a scientific instrument, but as a bridge to the stars, a time machine to the early universe, and a testament to what humanity can achieve when we dream big. Thank you for joining this journey through the cosmos. Keep wondering, keep asking questions, and remember, the universe is waiting for us to explore it.